Thank you so much, Vivek, for this opportunity. And hello, everyone. Just a quick introduction about me. I work as a lead data scientist, and I have some experience on using machine learning, deep learning algorithms, and different type of use cases. So this is an interesting meetup, I would say, rather than me only presenting. I want everyone to participate and also discuss, right? These papers are like, or these area is moving so fast that it's really difficult to keep pace with the things that are in each segment that are happening. So today, I mean, we are going to discuss about this survey paper. Let me share my screen quickly, and once let me know once you guys are able to see my. Okay, can you see?
Yeah.
Great. So before I jump into this paper, basically we want to set a quick context here, that I know that some of you may have some background of uh, understanding language models, and even prior to that some understanding of deep learning, or you may not have understanding of those, right? And if you are basically part of these, this is going to be like little boring for you, I would say. But if you are already aware of things that are happening, or at least some idea about it, uh, you will be able to understand things in terms of uh, how things are actually happening here, right? So I probably discuss about multiple things here. It's a survey paper, as you understand. So when we talk about one paper, generally all the papers are like chain of linked to different set of papers, right? So a lot of things that are that happen behind. Like if I have to talk about GPT-3, for example, I might need to talk about the evolution of transformer a little bit, and then from there where GPT-1, GPT-2, and different versions came, and then some improvements over each of those models, right? So similarly, this is again not one single paper, but it is an survey paper, right? So probably we'll not be able to cover the complete paper based on how you guys ask questions, and also but we will try to at least cover things that are kind of make sense, and and whatever happens in this 1.5 hour, nothing planned, so it is just, as I said, as Vivek mentioned, it is a paper reading session, not really delivering or knowledge, kind of I am just transferring the knowledge. It is basically everyone can contribute and also think about what we can discuss on this, right, further. So with that context, let's get started. So I probably would like to know that how many of you here already have some idea about LLMs, and how many of you don't have any idea about LLMs. Just you can just give me a thumbs up. Yeah, Anand is there. um, okay, Suresh, Ashutosh. Okay, quite a few folks, I can see. So that's good. So you guys can also sometimes help me if I am going wrong there, because the thing is that it's a huge I mean set of things. When I actually see, I mean, let me go through, walk you through this paper, that before we even jump into the single concept, that where it actually came from and what we are discussing here. So this paper has almost summarized 107 papers. So if you look at the references, this green numbers are basically representing how many times they have referred, and the maximum you can see that 108 is there. So if you go at the bottom of this, right, so these many papers or I would say the ideas that they have been talking about, right? Yeah, so 108, right? So I mean, in one discussion, it is difficult. I mean, it is a survey paper, but we'll touch upon the high level stuff and probably where it is required to go in some of those papers. We'll refer to those, but it is not possible to go in each and every paper and discuss everything, right? So that's kind of we'll try to limit ourselves there. Okay, we need to set some boundaries because it's a huge ocean of knowledge. um, so before we start that, so first thing that this paper, what is the headline says is that a survey on multimodal large language model, right? If you just have to break this into single, like words or tokens, right? Tokens are kind of nowadays it's very famous. So you know for some network issue, let me turn off my video. It might be challenging sometimes. So just, yeah, in Google Meet, I'm not really habituated, but yeah, I see that some options are like, yeah, fine. So, all right. So I think it is presenting again. Yeah. So I was saying about these three the terminologies that are being used here, right? So let's talk about multimodal first, and then we'll anyway, like some of you have some ideas about language models, if not large language models, right? So um, I'll like probably start with some examples there later on. So what exactly is a language model and what is a large language model? Can anyone would like to give an input? What is a language model and what is large language model? I mean, just thought. Okay, no one. All right. So let me quickly brief about what exactly is an LLM, right? So the thing is that these models, these language models, or when a simple language model came at the time when we were, I remember I was discussing the same thing in Cellstrat around 2018, right, Vivek? So it was a long time back now when we started these things. So the thing is that this BERT, which is a language model and been trained with some, I mean, I would not really specify the numbers, I don't remember, but let's say huge amount of text or corpus, right? So and it is built on that corpus. So and that model can be used for doing certain tasks based on, let's say if it is trained on Wikipedia data, you might ask some questions related to Wikipedia and the model is able to answer that, right? So you are building a model or training a model based on certain set of data set, right? And basically that you are calling it a language model. Now the term that large comes into picture when you are basically talking about huge amount of parameters, right? So from, let's say, probably in the parameters in millions, right, to you are going to billion and even trillion, right? There are models coming in future, might be that will be in trillions, right, parameters. So that's where we can say that these LLM or large language models come into picture, right? Now there are many variations to that. There are many models that came in. There are open source model, non-open source models. There are, a different way of doing building these LLMs. Now we are not really going into this LLM thing, I mean, in detail, okay? Because this paper is about little bit beyond that. Let's say we have got LLMs, okay? Today, like, you have this chat GPT, right? So let's say GPT is one of the LLMs. So you have got LLM, and now you are talking about a separate set of inputs or different type of inputs that you want to basically use these models with, right? So multimodal is a way to give different inputs. So um, let me quickly summarize that what are the things we are going to discuss. So this MLLM, right, multimodal language model. So it has multiple variants, right? Something like MIT, MICL, MCOT, and LAVR. So on each of them have, you can see that some of the trees that talking about modality bridging, data evaluation of that, right? Similarly for MICL we have modality bridging, learning paradigm, chain config, and generation patterns. And for LAVR also we have things like functions, training paradigm, evaluation. So we'll just have a look into these different aspects of each MLLMs. But before that, let's understand that what exactly this multimodal means, right? So multimodal refers to the ability of a model, right, to work with more than one kind of data, right? Probably image plus text, or text plus sound, or let's say video plus text, right? It could be video plus text. So now this is something that I think more like human, right? I mean, honestly, if you all of you have now by now familiar with chat gpt and used chat gpt, right? But what do you think that chat gpt could, I mean, sometimes limits I mean, probably the expectations, as we wanted to have both images. Sometimes you feel, right, oh, why can't I just upload an image and I wanted it to describe it, right? So as a human, I think that's the bridge it is filling up, the multimodal language models. Because when you have one kind of input, either you feed in only image or either you feed in only text, it is definitely solving some problems. But what is the idea of these multimodal language models is to, like, give different set of inputs and try to extract information from these LLMs, right? Now that's fine. Like, okay, we understood. We wanted that, but what are the challenges? There are many challenges. Like, you need to either you need a training for that, right? So you need to feed in images and text, and probably, like, you need to also have a proper data set for that, so that the model can be trained on properly, or fine tuned on properly, right? So those challenges are there. So when there are challenges, there are solutions also, like, so these as I said, this survey paper is talking about 108 references, right? So one of the references are talking about something called LoRa, right? Is anyone heard about LoRa? LORA? Okay, Ajay is saying yes. All right. So uh, this is one of the techniques, right? Where you are trying to solve this challenge of not really training or fine tuning a model from scratch. I mean, scratch in the sense, generally when you fine tune, what happens that you basically train on all the parameters, right? If the model is trained on 10 billion, let's say 10 billion parameters, right? You are fine tuning in all the 10 billion parameters, right? So it is, again, if even, like, if you are not really training from scratch, if you're doing fine tuning, that is also costly. You need GPUs, correct? You need GPUs for that. So and not only that, there could be other challenges, that the model might learn more on the text side, but less on the image related stuff, or less on the video related stuff, right? So these challenges are there. So it's a balance that you need to also form. Okay, just moving away from this thought of multimodal, I hope that thing is clear, right? That what exactly is multimodal. um, Now, GPT-4 is claiming that they are multimodal, although it is not yet released, no internals, no architecture has been published. But I read 2, 3 papers eventually to understand this, and what I figured out that a paper that is in difference of 2 weeks, in July, I mean in June, it was published. One paper is saying GPT-4 has already implemented multimodal very well. This paper, which is a summary, it is talking about that GPT-4 is not, we are not sure, basically, that it is also June 23rd paper, right? So we are not sure that whether GPT-4, and how GPT-4, how much multimodal it has implemented. But it is, if news is there, then definitely they might have implemented it. But what level, what kind of data they have used, they do not really publish those information. Okay, so so now let's see that what exactly is these models are trained with, right? So how we do that, how do we bring multimodality, right? So one is that you use image tags, you use image attribute, or you use intensive captioning, right? The image tags are like use clip model. So there is another thing that is called clip that we'll talk about. So clip model to generate tags of an image, and then you use clip to again detect object inside the image, and then you use blip to generate captions for the image, and that this whole thing you feed into the language model. Language models are already trained with lots of text, right? What it is not trained on is these information about the images. Let's say you want to do image, probably an story generation out of an given image, correct? So if that's the use case, those kind of things that you will be thinking about, well, you use these 3 different techniques, right? Now, this clip is one of the method. There are many other methods, but which is more popular. And so what they have done is they extracted image tags, image attributes using clip method, and basically feed it into the language model. Now, if we say about clip, right? So clip is basically connecting text and images. I mean, it sounds like something very sophisticated, but this is what is clip is, right? So you guys can go to OpenAI and check this clip, connecting text and images. So I probably will just give you an idea about this clip, because it's important. We are talking about multimodal models. So you can see that we are introducing neural network called clip, which efficiently learns visual concepts from natural language supervision. Clip can be applied to any visual classification benchmark by simply providing the names of the visual categories to be recognized, similar to zero-shot capabilities, right, in GPT-2 and GPT-3. Now, there are different type of data sets, which we'll talk about a little bit later. And there are some background and approach. So um, generally for images, right, and how you use these encoder models. And today there are things like the VLLMs, right? So and you try to get visual representation of these images, and based on the feature extraction from those images. Now I'll probably come back to the paper, and we'll come back to this again if needed. And there is something called blip, right? So blip is a more of more focused towards, I mean, again, that is also a concept for generating the image related information. Now, there is something, there's a paper called instruct blip, right, which is meant for instruct. So we'll see this in paper. We have used this instruct blip a lot, referred instruct blip a lot. So instruct blip is like, basically, it's a vision language model. Okay, VLM. Okay, I'll say vision language model. So now this blip is being used for intensive captioning, right? Vision language model was like, um, some time back, it was published by one of, I mean, the Hong Kong University actually, and Salesforce research, right? So both collaboratively they did that. So the primary goal of that model was, um, querying these LLMs and try to get the captions, right? So I'll talk about that a little bit later. Again, come to clip and blip, because it's important to understand these multi-language models, multimodal language models. Okay, so any questions, anyone?
Yeah, on chat there are comments.
Okay, let me see. Um, uh, okay, Vanumati, output of image models for images are passed to LLMs. Yeah, that's right. I mean, it is not the only way. We'll talk about it, but this is one of the ways. Yeah. So you can basically use intelligent models to feed into the LLMs, or normally how we feed into GPTs nowadays. If you, all of you are using chat GPTs, right? Probably you are, either you use API. If you are not using a production, I mean, production ready project for using chat GPT APIs, I would believe that you are normally, if you are like asking some, writing some code, or you're asking to summarize something, or asking to generate some text, right? Really don't care, like, thinking about too much into how the input should go. But let's say, when we are talking about this prompt engineering techniques, right? So there are so many sophisticated techniques that are coming out, and one of the things are that, so multimodal is the way that you provide the input, but uh, there could be, like, more sophisticated way, in the sense that you have a thought, and when we ask questions to someone, right? You might ask me a question based on your understanding, and you ask a question, and then I give you some answers, probably based on my understanding, and then you try to say, no, I didn't mean that, can you clarify a little bit more on the other aspect, right? So this is how we humans try to ask questions to other human, right? Another human whom we know that he probably can answer that. Now, normally when we are interacting with chat GPTs, we are giving a set of input. Let's say, probably, like, write write a paragraph about mountains, let's say. Okay, or I will probably specify uh, some region. Okay, let's say some region, Alaska or something, let's say. Okay, Alaska mountains. Now this chat GPT is going to get that specific question, but there is no analytical reasoning happening there, right? So we can think about those aspects as well. Okay, and there's a comment here. Are these LLM trained on specific domain and industry, or its giant repo of training data set like ChatGPT? So here we are not talking about any specific LLM or domain. I have specified that while I started, right? Why? It's a survey. Okay. So now there could be different models that are being used for different purposes. Now, Chat GPT is very sophisticated. You can't really, I mean, I would say over the time there could be some models that will come and beat Chat GPT. But let's say I'll talk about the GPT-4 as the most advanced and production ready model. Okay, now because tomorrow lots of applications are going to be built on based on GPT-4, right? Or probably if there are some competitors of GPT-4, those are also like going to be built. Now, as anyone have heard about, like, I mean, just to answer Bonik's question, that are these LLMs specific domain, anyone has heard about Bloomberg GPT, right? So okay, Rahul, Ajay, everyone heard about it. So see this, when then now you are talking about domain specific, but regardless of domain, even if it is specific domain, how is it different in terms of uh, the way you ask questions? The questions will be different, but the way you ask questions may not change a lot, or probably you will design certain way to give inputs to these LLMs, right? And that's what we are basically talking about here, Bonik. Yeah, there are many. I mean, it will keep on coming. There is no end. I believe this is the time is like this generative AI is exploding. You can see that for one survey that is just in 5 months, there are hundreds of papers, right, Vivek? So, I mean, you know, when we started in 2017-18, probably we used to see this transformers, similar kind of model comes in 2, 3, 4, 5, 6 months, right, Vivek? And so
Yeah, I'm thinking what happened to all of my AI knowledge is no longer relevant because maybe learning things rapidly, but every month the goalpost is shifting forward.
yeah, absolutely. Yeah, I mean, it's kind of creating a little bit anxiety, right? Are you guys also feel little
So
anxiety?
there is a term called AI anxiety. Okay,
AI
there is a
anxiety, yeah.
term which has gone viral, AI anxiety. So because everybody is worried, how fast, what is this, and how fast it's moving.
Yeah, yeah, absolutely. So many things, but that's why I said, like, we have to set a boundary. I mean, I know that questions will come into multiple things, but we'll set a boundary and we'll try to cover only those aspects little bit. It's huge, it's the ocean. I mean, only the new things. If you just leave about the past things that happened, deep learning, RNN, LLM, transformer, BERT, robot, bard, lot of things there, right? So okay, Rahul saying, where does Bloomberg GPT use Open API? I mean, in what ways it uses Open API, or they have created their own LLM? Computer science fundamentals don't change, and LLM fundamental. Yeah, absolutely. It don't change, but the new learnings that, I mean, it's like, I give you every day. The fundamentals won't change, but if you have to learn every week some tools, right? Probably I can consider these, each paper is going to build another set of tools there in the market. It's fundamentally it won't change a lot, but the way that these area is moving, right, at this pace, and right now it's not just limited to the fundamentals of LLMs, and that is, I mean, that knowledge is more than enough to gain the other things, right? You also need to understand that how these LLMs are being used. People are talking about, I mean, probably let's say 4 or 5 years back, when we learned about BERT or language models, and there were no much use cases. People were only thinking about question answering generation or probably summarization, that too not very sophisticated, right? So from there, if you see GPT, fundamentally that has not changed. But what has changed is the intelligence and the level of interaction between common humans to these models, right? And which is also dynamically changing the whole aspect of AI and using AI in different business use cases. I know that there are so many industry leaders here on this session. You guys can add your inputs, but that's what I think. That's what I believe. Okay, Gopinath is saying AI is computer engineers Frankenstein. Yeah, absolutely. Okay, so we are not yet into this survey. So the abstract of this paper is basically talking about the multimodal language models, and which is the recently has been the new rising research hotspot, right, which uses powerful language models. Now, we are not specifying any specific language model here, but it could be any language model as such, right? Okay. Rahul, I think you are getting the answers from audiences. Thanks so much for taking care of that. So, so LLMs as a like brain for these multimodal tasks, right? So the primary thing that we are talking about that we can discuss the key techniques and applications in including multimodal instruction tuning, right? And then there is multimodal in context learning, MICL, and then you have multimodal chain of thought, MCOT, and LLM aided visual reasoning, LAVR. So LAVR is also kind of LAVR and chain of thought. Both of them are like becoming an hot area, which is again I would say it's an subdomain of the way that we do prompting for these LLMs, nothing else, right? So and finally, we'll discuss about the existing challenges and point out the promising research directions. Okay. So, all right. So, there is a GitHub for this. You guys can go to just you can search this paper and go to this GitHub and have a look what are else there. Okay. So in the recent years, I have seen that remarkable progress of large language models, right? By scaling up data size and model size both. And these LLMs basically raise amazing emergent abilities, typically including in context learning, instruction following, chain of thought, and these ICL, COT, and I mean, if I just say in short form, right? These are again, I said like a technique of doing a conversation with the LLMs. Ajay, chain of thought is yeah, kind of fine tuning. Yes. So we have learned about this zero shot, right? Earlier, a few shot, and then you have something like you can say zero shot, few shot. There are many ways, but I'll just probably touch upon these little bit. And when you talk about, so these are like more sophisticated method of doing not zero shot but few shot, and uh, basically revolving around that, these ICT, ICL, COT, everything. Okay, so we'll go there soon. Okay, so in light of these complementarity, I mean unimodal LLMs. Unimodal means like you're just if you're passing only images or only text, that's kind of unimodal. And vision models run towards each other at the same time, and right. So we are saying that formally it refers to LLM based models with the ability to receive and reason with multimodal information. So from that perspective, artificial general intelligence AGI MLLM may take a step forward from LLM for the following reasons. What are those reasons? First is MLLM. or multimodal language models is more in line with the way humans perceive the world, right? And our like humans naturally receive multi-sensory inputs that are often complementary and cooperative. Therefore, multimodal information is expected to make MLLM more intelligent. That's what I think even we as a human expect, right? We want these models to not just respond to textual information, but also probably a video, or probably images, probably sound, right? As we are moving towards making these models more like human, how humans perceive things. So MLM offers a more user friendly interface, and thanks to support of multimodal input, user can interact and communicate with the intelligent assistant in more flexible way. And MLM is more well-rounded task solvers, while LLMs can typically perform NLP tasks, right? So MLMs can generally support a large spectrum of tasks. Um, let's hold the thought here, and we'll see that how the things happening with uh, another model called Blip, right? So uh, I'll come to that. So there is, like, when you do prompting with ChatGPT, right, for multimodal reasoning, this is uh, something that is published by Microsoft Azure AI. Uh, you can see that visual math or text reasoning or visual conditioned joke or meme, right? So you are basically passing in a particular image, and you are asking the model, or expecting the model to answer based on that, right? So there are some small examples given here. So ChatGPT, this image contains two celebrities, Kobe Bryant and Sis. They are both basketball players. So now you're saying how many championships rings did the player on the left win in in his career, right? So now it is basically giving those answers as well. So I really love this one, that visual math and text reasoning, where you have an image of the visual
Indrajit,
math.
are you showing the other screen? We are seeing the research paper only.
Oh, is it? Okay, I'm sorry. So 1 minute. Yeah, seeing it is showing only one window. Let me, thanks for that. Yeah, so now let me, how about now?
Yes.
It's showing.
No, browser, empty browser. Yeah, there is maths and
Yeah, so
coding.
now you see this AI. So this is like, we are asking AI that this is an image. AI is explaining that AI, that this image is likely a math question. This image contains 10 math equations. Now you're saying what is A in this first question, right? So 5 plus 2 is 7. It's saying that the value of A in the first equation is 2. Similarly, what is the Y in the last equation? I mean, it's a video, so it's getting to repeat, but I hope you got that right. So this is how and interaction of this MM. It's developed by Microsoft Azure. The prompting ChatGPT for multimodal reasoning, right, and action. So you're feeding in an image, and as well as you're asking the questions based on that image. Make sense?
Yeah.
Okay, so similarly, there are more. You guys can check this out, multimodal react.github. So there is a receipt, and it's AI saying this image is likely a receipt or ticket. It's a receipt of flight purchase made by debit travel, and so all the details it is extracting from that using OCR and all. And then it's saying that this image is likely a screenshot of a taxi, and this is receipt for Uber ride taken by Stephen. The total cost of these, all these things are like coming as in multimodal, both text and image, and the description of that image. So that's what is one of the other aspects of or looking into this different type of inputs that we can give. Now, I was talking about this instruct blip or instruct blip is something that came from Salesforce research and jointly made by them. So let me just quickly get that paper here. So the thing is that these, let it load. I'll come back. I'll take a pause if any questions here.
So Indrajit, as a MLLM, so the first step or the simple model what we are seeing is now the power of LLM plus OCR compatibility. It is able to read and convert and then convert it into text, and then it goes as per the LLMs.
Yeah, right.
So we can understand like that.
Yes, we can understand like that.
Okay.
I mean, it's not just OCR, right?
It's not just OCR, but we have to think in this way, that what kind of input we are giving to the LLM. Earlier, that LLMs are like mostly text-based thing, but as a human, we want also these kind of reasoning, solving problems based on images. And now this AI is able to extract that. Let's say there are sophisticated models from the vision area, and also you are using LLM, combining that input to the LLM and along with your set of reasoning questions, right, for that. So that's what we are trying to do.
So can we see an example where, like, in the playground area, what you've shown in that,
yeah,
the understanding from the images and then giving the reason, we are to see that, no, the second one.
Yeah. So let's take about
The Tom and Jerry one.
Yeah. So it is a yeah. So it's a image again. It's loading, just a moment. Yeah. So this is an image. This image is likely a cartoon illustration of squirrel holding a camera, right? So now the quick prompt is, why would a person find this image funny? That's the prompt. And AI is going to answer for that. So the humor is, this image may come from the depiction of a squirrel holding a camera, which is humorous and unexpected image. The cartoon style of the illustration, I can't read that, but I hope you guys got that. So that's what is basically two different type of multimodals, right? Two different type of inputs that we are giving and using the LLMs. Now, before LLM, we have these different techniques which we are going to talk about. That's why we came to this paper actually. So if you see these multimodal language models, there are techniques like MIT, MICL, MCOT, and LAVR, right? So again, that is basically deep dive into these type of getting into these kind of outputs or different type of outputs, right? And so yeah, so it is not just only that image plus some text, but it is also an intelligent way of doing that prompting, right? Like if you see that another important paper, there is a paper called tree of thought. Anyone have seen that tree of thought? So okay, Ajay probably reading those papers. So tree of thought is like, I mean, I'll not really dive into that, but let's say you ask some question to ChatGPT, then you have a thought, you ask that, you have another thought, you ask that, you have another thought, and then it gives you some answer based on that. You ask something, then you ask something. The tree of thought is like you have given three different type of inputs, and based on your three different thoughts, and that gave you some outputs, right? Probably it could be multiple things that probably that will trigger another three thought or three or four different thoughts. So you will go in this tree, architecture to ask reasoning questions. So what you are doing is you are not expecting the model to answer things in one shot or one go, but rather you are keep on reasoning to until you arrive at the answer that you are looking for, or that is more satisfactory to what you are looking for, right? So you are, and there also, like, there could be in like things that people are thinking about to bring automation or and way of automating that, generating basically thought generation, right? So different thoughts that are being generated as a chain of thought, and you feed that as an input to the LLMs. Again, so those discussions are around the same thing that we are talking about, multimodal language models. Now, GPT-4, which ignites a research frenzy over MLLM because of the amazing examples it shows. However, GPT-4 does not open multimodal interface, and no information about model has been made public up until now. This is what this paper is talking about. But I saw somewhere that people are talking about the GPT-4 is also using multimodal. So just let's keep that aside. Regardless, it is going to happen soon, right? All right. So so we write this, I mean, this survey that they have written here, that we write this survey to provide researchers with a grasp of the basic idea, main method, and current progress of MLLMs, right? So sometimes it's good to see these survey papers, and it gives you a holistic idea around that. So I said, like, come back to this, that you have an image, and then you using this clip method, you generate tags of that image, and using again this clip method, you detect object inside that image, and you use intensive captioning, like use blip to generate captions for this image, right? So again, let's come back to this. So I said, like, the clip, right? So clip is a connecting text and images, which is another kind of model by OpenAI. And what they have basically said is that it's similar to zero shot capabilities of GPT and GPT-2 and GPT-3, but it has the capability of extracting information from images. And so if you look at these, right, so clip is a it pre-trains an image encoder and a text encoder to predict which images are paired with which text in the data set, right? And we then use this behavior to turn clip into zero shot classifier. So we convert all of the data sets classes into captions such as a photo of a dog, and predict the class of the caption. Clip estimates best pairs with given image. Okay, so you see this, that there are two different type of input that goes in to the regressor, right? And then you try to basically predict of that. So if it photo of a dog, right, this is what is happening here. So it's a data set classifier for labeled text. Okay, so not diving into it too much, but yeah, this is what clip gives you an idea
This
about.
is the primary way of correlating text to image or vice versa, right?
Yes.
So
Yes,
this was an
absolutely.
OpenAI paper or algo, which has become the dominant way of translating text to image or image to text.
Right. So visual classification task, right? And you basically narrow it down to that, you can see this here, that guacamole ranked 1 out of 101 labels. It has like a photo of, you can see how this is labeled as and predicted labeled as. And similarly, this is like a photo of a television studio, right? 90%. And it is talking about different data sets there, like YouTube BB, right? And ranked 1 out of 23 labels, which is airplane person, airplane, comma person. I don't know, they have written like that. So that's how this is happening with the clip. Now let's look at blip. So blip in the blip scenario, it's also June 15 paper. You can see that how is a very like very frequently this happening, these papers. Like, so it's towards general purpose vision language model with instruction tuning. And if I go here, right, so you can see that what could happen, what could have happened based on the current scene. So now it is basically you are giving such prompts, and you're feeding in some images, and you are expecting the model to basically give reasoning behind that, right? So I'll come to that. And this is using this technique that you have an instruction. So choose the correct option to follow question, which picture shows the pizza inside over, left one or right one, right? So these are the two images you can see. Can you guys see this?
Yes.
So choose the correct option to following question. Which picture shows the pizza inside the over? Left one, right one, right? And you give an input image, and that goes as an embedding to the Q farmer. And now Q farmer is again fully connected network that is going to the LLM along with the instruction that you feed in, right? The instruction that you provide, which is here. Okay, so two things, input and as well as the instruction, right? Now LLM is giving you the response that it is the left one that it is talking about. Okay, now not really going into self attention feed forward, but I'll expect that you guys have some background. But this is what is blip and overall that it is trying to do, right? Using this vision language model, which they have called. Coming back to this, image tags and image attribute uses clip, intensive captioning using blip, right? So once you get this, the whole information that you got, you feed into LLM, right? Something like, there
No,
is an
Indrajit,
yeah.
fundamentally blip is image captioning algorithm.
It's not image captioning, but blip is combination of the two things, right? Um, I mean, without these prompts, it is just image captioning, right? But you are also feeding in an instruction with the image.
Okay.
See, normally in image captioning, you know better in the computer vision area. So what I think that any of the image captioning, we never actually thought of giving an input instruction as a text, right? We never give that. We just feed in the image and we expect the model to give us the captions.
Right.
So now you are doing little bit intelligently the same thing, but little bit intelligently using LLMs. Okay, so that's the difference. So the Q former basically is the one that extracts instruction aware visual feature from the output embedding of the frozen image encoder. Now here is one thing that I didn't talk about is when you do this, when you feed into these models. Now I told here that this is fine, like we want to do this image plus text. Now let's say you take a model, for example, talk about, let's say, Flantify. Okay, so Flantify is by birth it's a LLM, right? It's not an something that you will expect to be a MLLM, right? It's not a multimodal language model. That means it doesn't really take images and image related information. You probably can do text only, but no image feeding, right? So to make that model understand image related information, or I would say image plus text, you need to do certain kind of, either you train the model from scratch, which is very costly operation, or either you do fine tuning. Fine tuning also needs GPUs, right? So both are basically, I would say, costly operation, because it's not just we are talking about some amount of data that you do, but you over the time you need a lot of fine tuning there with so many images as based on your domain use case. Now the problem with that is not only the pre-training, and also like how you do that, right? So that's where this LoRa came into picture. Okay, so I talked about this, that how do you feed in, and then I talk about that how you do this fine tuning for the language model, basically to prepare to be a multimodal, right? So LoRa is a low rank adaptation of large language models, large language models. So the drawback of fine tuning, okay, first let's get that. What is the drawback? So new model contains many parameters as in the original model. Like if I have a model that is trained with 1 billion, you are basically training 1 billion parameters, isn't it? If you are doing fine tuning, you are basically doing fine tuning for 1 billion in a normal scenario. That's the costly operation. So a large language models are trained, let's say, and then you have done that. Let's say GPT-4 has been released and you're working in your use case in an organization, and next month GPT-4 released another version of that. Now what you will do? Again, are you going to take that fine-tuned model, which is sorry, that large language model, and again fine-tune it, or whether you will use your own that you have done probably, let's say by now it is 4 months and you are already thinking about what to do, right? So those are the drawbacks of doing fine-tuning. I mean, it's not, even if it is, let's say you can have GPUs and it's affordable, but it is not really feasible all the time, right? So those are the drawbacks, right? And now what is the possible suggestion for that? Possible suggestion is use only few parameters to do fine tuning, not in all the parameters. Okay, that's the idea that came. But for that you have a trade-off, that efficiency and model quality, right? So you won't get both. You'll have to do a trade-off between the efficiency and quality. If you are doing it with all the parameters, definitely you have to burn that much of GPU compute and also time and money, right? And if you are not doing that, probably your model will be more efficient, but you might not get that quality, right? So these are the two things. So for that, again, there is a possible solution that came in, that is, learning from you know it is basically the low intrinsic dimension. So they have taken an inspiration, this LoRa, low rank adoption of large language models. What they did is they basically took the dimensions that are more I would say more dense, because not all of the layers will be dense in this neural network, the large language models. So you will only take out the dense layers and you will fine tune those, right? So you are basically using using a filter method of what to fine tune and what not to fine tune. But remember that this is also, again, it's bringing a trade-off, right? The trade-off between computational efficiency and model performance.
Now, are you reducing dimensions using LoRa? It's a compression technique, right? So you're reducing dimensions.
Yeah, it's a rank decomposition technique, right? So you are doing rank decomposition. So by reducing the rank, you reduce computation complexity of the dense layers. Okay.
So this is different than dimensionality reduction.
It is different than dimensionality reduction. It uses a similar technique, but the approach is different. I mean,
Okay.
like we have in dimensional reduction, also we use SBM. Here also we use similar technique, but the approach to get that basically those models which are having higher dense layers, and you then do the rank decomposition for that. Okay. All right. So that's what low rank adoption of large language models is. Now, the thing is that, as I said, this LoRa is kind of helping you to make solving the problem of fine tuning a large language model for the purpose of bringing it or making it multimodal, right? Because by default, any of the language models are not multimodal. That does that clarifies everyone?
Yeah, Indrajit. So, is it been under research or it has been released, LoRa models?
No, it has been released, and lot of places they are using LoRa already.
Okay.
Yeah. You might have seen that even deep learning AI and Indrajit, they have released a course with the LoRa and other concepts.
Okay.
Yeah. So I believe it is going to be stable in this instability. so okay. So moving ahead to this paper again. Sorry, I need to jump on to these small concepts that are important to understand this. So I hope that's fine to all the audiences. It's a paper reading session, not really no, not really. My goal is not really delivering any kind of that I only know things, but
No, we are getting both the benefits, Indrajit. We are getting the paper and we are getting the concepts also. Thank you for that.
okay, great. Thanks for the feedback.
Yeah, I
So
think the boundary between education and collaboration is thin here. So it's okay. So we are discussing as well as learning.
yes, absolutely. I want the same way, not the one way. So yeah, please feel free to give your inputs. Okay, so there is this multimodal GPT. Okay, and multimodal GPT is, I just talked about this visual language model, right? Few shot learning, where you basically now you know probably these guys are trying to do many ways to have the same to arrive at the outputs, right? One is image plus text, or text plus text, or uh, uh, two different images and then text. So it doesn't matter ultimately. I believe that it's just following a sophisticated way. I'll come to this again when I talk about uh, these MCOT, MICL. So before that, I was talking about these layers of training, right? So what happens that is multimodal GPT, right? In multimodal GPT consists of a vision encoder, a perceiver, that's a resembler to receive the spatial features from the vision encoder, and a language decoder, which is conditioned on the spatial features from the perceiver resembler by cross attention in order to encode the feature of vision into text. I mean, we are not really going into there, but what you understand is this green one, trainable LoRa, right? So once you do that rank decomposition, you will not really so again, we are not really training the whole thing. We are freezing all the layers, but only we are training the layers that are necessary, right? So we freeze the whole open flamingo model and add LoRa to the self attention part, the cross attention part, and FFN part in the language decoder to fine tune multimodal GPT. Okay, this is one of the approach using LoRa. So you are only basically you are freezing all the other layers and you are focusing on certain layers. That's the whole idea here. Okay, now let's come to the comparison of three typical learning paradigms. I mean, by now I think most of us aware of these prompting techniques. So the first one is that you have a pre-trained language model. You fine tune on task A, but typically requires like many task specific examples, one specialized model for each task, and then you get the inference. The other thing is that the B type, that is prompting only, where you have a language model and you improve performance by few shot prompting, right? A prompt engineering. So does anyone like not aware of zero shot and few shot, or you want me to repeat few shot, zero shot, few shot? You can put it in the chat.
Sir, if time permits, can you just give a summary of that zero shot and few shot in a minute or so?
Yes, Abhinav. I think mostly everyone is saying they know, but I'll just quickly tell you. So few shot or zero shot means by the name by that term zero means you are not really giving any kind of instruction, I would say, or additional information. You're asking like tell me the sentiment. Probably like just saying tell me the sentiment of I am not doing good, right? So something like that is a zero shot because you are not really giving the model any kind of instruction or additional information. Few shot is something that where you tell like I have this sentence which is negative, I have this sentence which is positive. Can you tell me what is the sentiment for this? Right? So which is basically a few shot way. Now,
Sir, one question, sir.
yeah.
As we give input to these two different shots, on what parameter it's defining the problem? Like it will go to zero shot or it will go to the one shot, few shot. Is it like integers involved which are giving us full-fledged information regarding the question? That's why it's putting into the few shot, or it's something different.
So yeah. Anyone? So the thing is that if I understand your question, normally for any LLM, right, you give an input and it gives you some kind of output. So that input, now we are not really taking care of uh, how or which mode this it is integer, it's a vector, right? So it's a query for the LLM. Now LLM is not really bothered about whether the input is coming as one single without instruction. But now when you are giving multiple inputs, as in like with an instruction telling that hey, I want only JSON format response, okay, so the language model is noting that down, and it is also trying to give you the output only in, let's say, JSON format because you have specified it. So in zero shot, the model is not really expecting that you are giving any additional information. So the model has already trained on certain sentiment tasks, let's say, and it is able to do that based on that, right? But when you are doing when you are doing let's say few shot, you are giving an input. Along with that, you are telling, hey, I want not only the sentiment, I also want you to describe about sentiment, right? So you're giving multiple inputs to the language model. For language model, it is going in the same form, in the sense that, I mean, if you are aware of that, any language model where we give inputs, we generally the previous layers, when we before we feed into them, right, we convert, or we basically get the embeddings that is matching with the query key, the QKB thing, right? So which is the query, the key, and the value, right? So you have this attention mechanism in place that are all comes into encoder, decoder, and transformer architecture. So again, going back to that level. But if you just, as in few shot and zero shot, if we should say the difference, zero shot, no instructions. Few shot, you give additional information. Make sense, Avinav? I mean, at least that's what I understand.
Yeah, sir.
Yeah.
Thank you, sir.
If anyone would like to add, it's fine, but otherwise we'll move ahead, because we only have 15 minutes time. So I mean, we just reached to the overview of this. So probably this multimodal, if I go back to the primary center of these, right? So you can see here that MLL has MIT, then you have MCOT, MICL, and LAVR. So if you just talk about MIT, right? First thing that we talk about data, then we talk about modality bridging, and then we talk about evaluation. Modality bridging is where you actually take care of that, how different type of inputs are bridged together and then combined and then sent into the language model, right? So here you have a learnable interface, you have an expert model. Now let's say, what is expert model is like, you probably think that you can have a text or as an input, and along with that there is a, let's say there is a large vision model, okay, along with the text. So this vision model itself could be an expert model, not just human level interaction or human level prompting, right? It could be an expert model that is also giving an input to the language model. So that's what is happening here at the modality bridging. And then you can see here that learnable interface that has query based, projection based, and parameter efficient tuning, right? PEFT. So PEFT is another important concept that probably we'll talk about later. We again come back to this paper, this part 1 discussion, because it will take time. So now the thing is that parameter efficient tuning is also part of the modality bridging. Okay. Now let's get into this MIT little bit. I'll just talk about the overview of that. So MIT, or multimodal instruction tuning, is a technique that refers to the description of tasks. So instruction tuning is technique that involves fine tuning pre-trained language models on collection of instruction formatted dataset, right? So tuning in this way, LLMs can generalize an unseen task by following new instructions, thus boosting zero-shot performance. In zero-shot, that's the problem. Like, you probably do not follow a specific method, or you probably not really sure that how the model is learning there. You're trying to control it by instruction tuning, right? So this is simple yet effective idea has sparked the success of subsequent works in NLP such as ChatGPT, InstructGPT, Flanty5, OptaML, right? So the comparison between instruction tuning and related typical learning paradigms are like, that is what is given here. That is what is given here. So you can see here pretend and fine tune, and then you have prompting, and then you have instruction tuning, where you have instructions tuned on many tasks, B, C, D, L. Like, the model learns to perform many tasks via natural language instructions. Okay. So instruction tuning is highly related to multitask prompting. That's where it's coming into, as in narrow it down to, right? So in order to extend from unimodality, like you are only giving text, only giving image, to multimodality, the corresponding adaptations are necessary for both data and model. So we need to take care of both the data as well as the model, right? Not just focusing on the data, right? So if you just go at the first thing that comes into picture is, that is, you can see here MIT. So it has data, modality bridging, and evaluation. So they are talking about different type of approach, like manual approach, and then you have GPT aided, and then data collection, you have benchmark adoption. I mean, you basically collect only the benchmark data. The problem with those, there are challenges and problems with that approach also. And then you have self-instruction, and you have hybrid composition, right? And these are nothing but the papers associated to those areas. These are different papers associated to all the green numbers that you can see, all are one single paper, right? So that's how this is. What about data collection? Then you have modality bridging, where you talk about learnable interface, expert model. Sorry, not this. So these two things, right? Modality bridging and learn expert model. So now query based, in that you have projection based, and then you have parameter efficient tuning in learnable interface. If you go to that now, preliminaries. So what we are doing is, formally, a multimodal instruction sample can be denoted in a triplet form, I, M, and R, where I, M, and R represent the instruction, the multimodal input, and the ground truth response. Okay. So these are the three things that are basically fed in. and what you are expecting as an output is the and basically an answer, right? So A denotes the predicted answer, and theta are the parameters of the model, right? So the training objective is typically typically the original autoregressive objective used to train the LLMs, based on which the MLLM is forced to predict the next token of the response, right? You can see that the objective can be expressed in mathematical equation. Now we are going into the one part, that is the modality. You can see here modality bridging, right? So and modality alignment. So now, I mean, before we talk about that modality alignment, there are things like, you talk about data. So the data is very important, right? What data it is has to be like feed it in with, right? So the collection of multimodal instruction following data is a key to MIT. The collection methods can be broadly categorized into benchmark adaptation, self-instruction, and hybrid composition. Either you use one of them or you mix both of them. Okay, that's right. It's kind of asking different type of question and seeking the subjective and objective answers. Right. So the benchmark adaptation is like benchmark data set are rich sources of high quality data. So hence, hence we have utilized existing benchmark data sets. So I'll just show you. I have taken a screenshot earlier from that paper. So to see here some of these benchmark data sets. Somewhere I have kept that. Just a moment. Yeah. So you can see here this right. Image captioning, visual reasoning, visual conversation QA, video question answering, image captioning, reading comprehension, and image question answering, right? So these are like different type of data sets that can be used as a benchmark data set, right? It's an existing benchmark data set. Now it's saying that take the transformation of VQA. For example, the original sample is an input out pair where the input comprises as image and natural language question. So the instruction, that is the description of the task, can either derive from manual design or from semi-automatic generation aided by GPT. So we are basically trying to design that as well. Specifically, these are some papers handcrafted a pool of candidate instruction and sample one of them during training. So you guys can basically refer to these papers later on the set of benchmark adaptation, and there is a self instruction. So although existing benchmark datasets can contribute a rich source of data, they usually do not well meet human needs in real world scenarios, such as multiple rounds of conversation, right? So to tackle this issue, some works collect samples through self-instruction, which bootstraps LLM to generate textual instruction following data using few annotated samples. I mean, now you probably can have a hybrid of these, right? And then think about preparing the data. Hybrid composition. Okay, I hope that is clear, right? So now you can see an example here, table 2. There's a image and there's a question, and then you have a short answer to the question, and then you have another question and a short answer to that question. Given the image, answer the following question with no more than 3 words. It's an instruction that is giving, and based on the image, respond to this question with a short answer, right? Use the provided image to answer the question. Provide your answer as short as possible. Or what is the answer to the following question, right? And the question can answer using image, a short answer. So you can see the visual QA data set that is cited on this paper, and other image and question in the original VQA data set. So this is just an example of like using and hybrid method also, right? Okay, so I think we can take a pause here. We have few minutes left, and probably we can, once we do another session, what do you suggest, Vivek? So we can talk about modality bridging and going into that deep dive into that part.
Yeah, I think it will take easily 1 more hour. So
Easily.
so we should probably do another session later.
Yes.
I would say just sort of give an overview of what has been covered so far, even though the second half paper is pending. But what has been covered so far,
Yeah.
if we can
So we
understand the basics first, then we can go to the second part.
Yeah, so we have covered mostly around basics of LLM, and then we covered MIT, and from there we were basically directing through data, and we covered this part, right? Little bit, and then we next thing is that we have to cover this and these two, and then again MICL little. This is like not too much, but we'll cover MCOT and LAVR. MCOT and LAVR, we have probably a different set of papers. So what we'll do next is, Vivek, we'll not discuss the same paper, but we will approach from here to here instead of here to here.
Got it.
So we'll, because we have hundreds of paper only related to MLLM, right? So we can basically reach from there to these again. So we'll go deeper into that aspect of MCOT, probably talk about tree of thoughts, that paper, and then come back to MLLM again. So everyone who has attended, they can also relate to more, and if there are new audiences, they only will know about the tree of thought and how MLLM relates to that.
Yes, I'm understanding how this paper review has to go. It needs a series of discussion because each paper is very complex and it has a lot of interrelated thoughts and concepts which need to be explained before paper can be understood.
Yeah, it's a chain.
It's a chain, the paper chain, a chain
Yeah.
of COP.
Just like Lang chain.
Yeah.
Okay, Bonik is asking different URLs that I have referred. So I'll do one thing. This, I mean, there is a GitHub for this particular survey. In the same paper, you have all the links. So I'll share that GitHub, and if you basically go down to that GitHub, you will find like there are so many papers linked to that. So although I know that it is kind of difficult to see all of them, but yeah, you guys can try to relate with that. So let me ping. I talk about these multimodal React GPT IO, which is a good visually representing the things. Then I talked about LoRa, which is an important aspect, right? And Instruct GPT. So this one is Instruct GPT, and then let me ping the LoRa one. Primarily, these are the things. I didn't really go into too much into many of the things, so or else it would have confused. So this is Instruct GPT, and yeah, let me ping the clip also. So the research paper is in this OpenAI page itself. And the LoRa one. LoRa and PEFT. These are also the two different things that are very in-depth things that we should talk about. And then we have multimodal GPT.
And give us feedback on this paper review, which is sort of our first one today.
Yeah,
how do you feel about it? It's very complex, I know, and it has too many interdependencies with a lot of related concepts we need to learn. Do you all think this paper reading activity is sort of important, and how we can do it better? Any feedback?
Vivek, as usual, great initiative. Definitely, it is really good. No shortcomings at all, so that we can tell how we can improve. Definitely, we can do a lot of things, and appreciate Indrajit for all the efforts behind this. We feel they're so well prepared and then ready-made whenever he's talking the concept, and I think he used some magic LLMs so that the handwriting is nicely coming up, so nicely written handwriting. Otherwise, if somebody writes, we'll not understand. Even Andrew and G writes something, we'll not know what he writes. So, Indrajit's beautiful handwriting, makes the session we attend more and more. So, thanks a lot, Indrajit, for the deep dive. I know how much effort you have put to show that, and it shows your effort as well as your knowledge. Maybe with less effort, with your knowledge, you would have done it. So, appreciate it. Thanks so much because of all the participants and from my side.
Thank you, Anand. Thank you so much for all the feedback.
Any other thoughts or comments, audience? Thanks, Anand. Very nice feedback. So okay, so we'll continue this series of discussion by Indrajit in another session. So it is becoming clear to me we need a series of these, and this is just too much to sort of grasp. So thank you, Indrajit. Thank you all for joining. We'll see you in our upcoming webinars. In fact, there is one tomorrow, so make sure to attend that as well. Thanks, Indrajit.
Thank
once
you,
again.
everyone.
Good one.
Thanks, Vivek, for the opportunity. Yeah.
Thank you.
Thank you all. Bye.